evaluate the limit if it exists. And here we're looking at the limit as t approaches 16 of 16 minus t over 4 minus the square root of t. Now again, we cannot just use direct substitution, but even if we could, if you plug in 16 for t in the denominator, the square root of 16 is 4, and we've got 4 minus 4, which is 0. So even if we could, we would end up with a 0 in the denominator. And that's usually a good hint that we need to try and see if we can use some algebraic trickery here. So I'm going to rewrite this because we are going to make a change. So we've got 16 minus t over 4 minus the square root of t. And we've already seen situations where we've got a difference where one of the terms is a square root. And we know that, or we've seen that if we multiply by the sum of those terms for plus root t, that often gives us something neat that will cancel something out. So let's give that a try here. Now, when we do that, we've got the limit as t approaches 16. The numerator, I'm going to leave like it is. I'm not going to go through the trouble of foiling it out, especially with that square root of t, because there's going to be a lot going on there. But in the denominator, remember that when we've got a difference times a sum, that's the difference of squares. So we've got the first term squared, 4 squared, minus the second term squared, root t squared. And remember that when we square a square root, those things cancel, and we're just left with the inside, which in that case is t. So this is going to be the limit as t approaches 16, and our denominator is going to be 16 minus t. And you already probably noticed our numerator has a 16 minus t in it as a factor. And so we can cancel those factors out. And when we do that, that gives us the limit as t approaches 16 of 4 plus the square root of t. We're almost to the point where we can use direct substitution. But remember, we can't do that if we've got a radical, but we can take this limit of a sum and we can rewrite it as the sum of the limits. So the limit as t approaches 16 of 4 plus the limit as t approaches 16 of root t. And once we've done that, we can move the limit inside that root. So this is, let's just evaluate this limit now. The limit of a constant is itself. So that one is going to be 4. And then we move that other limit inside the radical. And then we can use direct substitution. The limit of t as t approaches 16 is 16. So we've got 4 plus the square root of 16, which is 4 plus 4, which is equal to 8. So in the end of all of that, the limit is equal to 8.